Hello everybody, my name is Glauber Costa and I'm a lead software engineer for Cloudius Systems. Me and my colleague Don Marti, we're going to talk to you today and show you a new operating system that we have been developing, and I will stress that this is a new operating system. It's not a version of Linux, it's something we wrote from scratch called OSv. It's an operating system designed to run Java in the cloud. I hope you're enjoying the conference, and I'm happy for you to be here post-lunch. I almost didn't make it myself, and I am certainly enjoying it very much. Not only the conference, I like the fact that this conference is in San Francisco, and I've learned it's really all over San Francisco, which is an awesome city. I'm a visitor here, I'm not local, and every time I come here, it amazes me how much there is to do in the city, how much there is to see. And I only here for a short while in very short visits. It always makes me wonder how much more I could do and how much more I could see if I had more time. Time is the most precious thing we have, all of us. No matter who we are or what we do, time is important in business and in life beyond business as well. I would argue even more important then, right? It's a finite resource. It's 24 hours every day and you're done. There's nothing you can do. Well, if I had extra time, I don't know about you, but if I had more time, there is a bunch of courses in Coursera. They're waiting for me, and I won't do it. I don't have any time. Don told me that if he had more time, he would learn how to play the guitar. And I'm happy I'm not really local from San Francisco, that even if don't have time, I don't have to listen to him in the beginning of his practice, right? I know how to play the guitar, and the beginning of it was not really good. It makes me wonder, like, all of you in the audience, what would you do if you had more time? And let me get specific here. I'm talking 13 hours extra time. 13 hours is more than a whole workday. 13 hours, as a matter of fact, is more than 20% of your whole work week. And still, this is the time, according to the Gartner Group, that developers and testers spend configuring their operating systems. Their general purpose operating system, and this is the key, their general purpose operating systems. This is not hard to believe. It's scary, right? It's money flushed down the toilet, but it is not hard to believe. The reason for that is that general purpose operating systems are the wrong tool for the job. They're the wrong tool for you to get your application and move it to the cloud. If I was a carpenter, I'm not, but if I were, and if all I had was a hammer and I had to do the job of a screwdriver, I would spend crazy amounts of time as well. But when you need to do that in carpentry, you just use a screwdriver. Now, our industry is fancier, but really is no difference. And let me show you the reason you spend so much time with your general purpose operating systems. This is the reason. This is a diagram that it was taken from Brendan Gregg's blog. For those of you who know Brendan, he is today, he worked for Sun, a creator of the D-Trace probes, and he's now senior performance architect at Netflix. Spends his days figuring out what's wrong with their systems. There is always something wrong, right? It's technology, it's not magic. But you need to figure out what it is. You need to interact with your operating system. And this is Brendan's cheat set on monitoring tools for Linux. Well, I'm not a Java developer. I'm an operating system developer. And I spent the past decade developing core parts of the Linux kernel. I don't know all of those tools. I seriously don't. It's not a lie. Well, I know a whole bunch of them, but not all of them. So kudos to Brandon, because Brandon actually knows a lot about this. And I'm not saying that you guys don't know those tools or that you can't know those tools, but is it really the best use of your time? Is it really the best use of your scarce resource of time? It isn't. OSv can do better because it is a library operating system. A library operating system is just like your average general purpose operating system with one main difference. It will only run a single application at a time. And in our case, the Java virtual machine. Because of that, we don't need a lot of the facilities. We don't need a lot of the infrastructure that a general purpose operating system needs to run. Architecturally, you still need an operating system to deploy your code. That's the way things works. That's the hardware-software interface. You can't be left without it. But a library operating system merges together with your application, the JVM in our case, as if it were a library. As the name implies, actually, it is a library, right? And by doing this, by writing this operating system from scratch with this in mind, that we're only going to be running a single application, that allows us to remove the OS drama for you. Right? Remove it completely. Move the JVM to where it belongs, to the center of the scene, as the main character, not as something that is just there in the middle of all of this maze of things Linux offers you. OSv is faster than general purpose operating systems, and I'll be clear, it's faster than Linux. Don is going to show you how much in the end of the presentation. We have benchmarks. He will show you. But that is not what I'm here to talk to you about today. Faster is good because faster allows you to run the same thing with less hardware, less resources. However, every organization has two types of resources, two types of capital stock. Hardware and people, the human capital, you guys. And this is way more valuable. This is way more expensive, actually, than hardware. So faster is good, but what we're going to focus at today is how OSv fulfills the promise I just made and saves you time by taking the OS out of it. We are faster because we run the OS and the application in the same address space. It's all integrated. I'll talk about that as well. But the key here is that OSv does not have a single local compatibility configuration file, except in some cases that the application expects the file to exist to run. Like, so the file is there. We don't want it to change our application. We don't want you to rewrite anything. Well, you don't really write code for Linux, right? You write code for the Java virtual machine, and that's why we actually have the Java virtual machine integrated in there. So this is a compatibility layer that allows you to leave your application unchanged. We have no local users. Again, maybe your application wants a user, and here's the OSv user. It's the only user in the system, right? Nothing to tune, nothing to configure, nothing to adjust. We have no package manager, no dependency tracking. You already do that with Maven, with whatever tool you have. You don't do that for the operating system. The operating system is there running the JVM, and that's all. And that runs in every single major virtualization environment. So here's the trick, here's the restriction. We only run OSv on virtualized environments. Right? That is part of what allows us to rewrite the full operating system. We don't really have to worry about drivers. We just have this small set of drivers, and we run everywhere. We run on Amazon EC2, which is Xen-based, for those of you who know the underlying technology, which means in your private Xen deployment, it runs as well. We run on Google Compute Engine, which is KVM-based. We run on VirtualBox for your private testing, And we run on VMware in your private cloud, whatever it is. If you need it, we're there. We run on every single major hypervisor. All of those applications that we have been testing and evaluating Cassandra, Jetty, Tomcat, and a couple of other non-Java applications as well. It's technically possible. It's just not our focus, right? And you have here all of those applications, all of those hypervisors, those clouds, public and private cloud. And in the middle, you have Java with this extra library. Now, because OSv integrates so nicely and so smoothly with your Java virtual machine, we don't actually like thinking of the combination of OSv and Java as OSv plus Java. That's not what it is for us. Java and OSv together are just Java. But it's a faster, it's not smaller, but it's smaller than it would be with the full Linux stack. Smarter, Java virtual machine that just boots on top of all of those hypervisors, on top of all of those clouds, and takes the operating system away. And if any of you has ever wished, I would just run Java without the operating system, OSv is for you. OSv is your wish coming true, if you ever had it. Now, I have a wish now. And we are approaching GA. Those are the applications, as I told you, that we have been evaluating. But if there is anything that you're interested in running an OSv, that you're interested in making sure that it's good, that it's smooth, that it does what you need, please tweet about it. We want to hear from you. We're monitoring hashtag OSv plus whatever application you want to run or you would be interested in run. We'll be there. We're going to take a look, and we want to make sure that your use case is covered. A little bit of the technical details of OSv. We have a very transparent integration with the JVM. And I have a slide specifically about that will give you one example of such integration. Again, we can do it because we run in the same address space. There is no user mode, kernel mode. You have the hypervisor outside, and inside the hypervisor, there is only the JVM. I don't need to protect you from anybody. Whatever extra protection you need, the JVM already provides. So that allows us to integrate very nicely with the JVM. We have sub-second boot times. A full OSv virtual machine will go up, run a simple application, of course, and down again in less than 1 second. Now, it depends, of course, on your environment. Now, Amazon will take a couple of minutes just to get your VM. So again, I'm talking to you about technology, not about magic, right? But if you run KVM, for instance, that's where we're testing most of it, and you're not using a very loaded BIOS or firmware, OSv goes up and down. It's the whole VM, the whole of it, in less than 1 second. That makes it ideal for your microservices, if you have them. If you have something that needs to go very fast, go down again very fast, OSv is there for you. We execute very efficiently, as I mentioned, and our management, that's what Don is going to demonstrate to you about. It's full rest. All of it. Not a single exception. All of your interaction over OSv matches your environment. And it's all of it rest. That's how you talk to OSv. That's how you extract data from OSv. And that's how you tune things in OSv. If you need, for example, Don is going to show you more about it, but I need to trace, I need to change the host name, or whatever, like, you need to do it. It's all rest, right? So this is a question?
On the management, is there libraries by which the Java app itself can do management operations from the inside?
Can you repeat that, please?
Do you have Java libraries by which the application can do management functions inside?
Yes, here's the thing. OSv, think of it as a library that allows you, so you need an operating system to boot on hardware. That's an architectural constraint. OSv is a library that allows you to boot on top of any hardware. After you do this, I just give you the JVM. I translate hardware to POSIX, right? That's what I do. Once you have the JVM, whatever you run on your JVM, you run it on OSv. There is no difference. So if there is any library, there is any packages, there anything that you run in your application. Now OSv comes with a full management that is exports a lot of the operating system internals, exports all of you need, but you just use it to integrate with your workflow. We're not mandating anything. Whatever runs on Java runs on OSv. Because again, you don't code for the operating system, you code for the Java virtual machine. This is a nice feature that is just an example of what kind of things OSv can do by being integrated in the same address space, operating system, and the JVM. So the JVM, because it runs in ring 0, has complete access to all the underlying hardware. And if you ever had to worry, what maximum heap size should I give to Java? You worry no longer, because this is the job of a machine, that is not the job of a human being. That is your time being saved. What OSv does, through this feature of memory ballooning, it allocates all memory available in the VM for Java. And when we need to allocate resources for the operating system, we get it from the Java heap. You need memory for caching your files? Fine. Get it from the Java heap. No longer needed. The JVM needed this again. Give me back. It's all transparent. You don't have to do anything. So if you do specify a heap size, we respect it. But if you don't, OSv is going to do it for you. All integrated, all transparent. That allows you to use your memory a lot more efficiently. Yes, of course, a general purpose operating system like Linux can page out your stuff, but it can't know what's in those pages, so you got to swap you. And we know it because we're inside of it. So we smartly say, yeah, let's call the Java garbage collector, free up a little bit of space. It's a couple of megabytes that the operating system needs, so it's a small collection anyway. Free up the space, give it to the operating system, right? It doesn't involve any swapping. It's memory to and from the operating system without swapping. It's the smart way. We also integrate with Julukia, if any of you ever use it. It's not our technology. This is Apache's. But we integrate that to, again, this is optional, but it's already integrated and available in the default OSv image. It just exposes all of your JMX over REST, over JSON. And that's one of the examples we're going to show you today, uses that as the underlying mechanism. Again, we aim for integration, with nice integration with the JVM, and forget about the operating system. Forget about gain back those 13 hours that you have been just throwing away by configuring your operating systems. And with that, I'll leave it to Don, who's going to show you more about the management side of OSv and a demo.
All right, thanks, Glauber.
So if you need it.
Oh, okay. Now I have a more powerful laser pointer. All right, so when you're building a virtual machine for deploying your application, that can sometimes take quite a while, right? You're taking a complete operating system, you're installing a bunch of packages, you're installing a bunch of dependencies, then finally you're installing your application on top of that. The approach that we take with OSv is a little bit different. What we do is we can take that VM build process and tie it straight into the build that you're already running for your application. So if you're running Ant or Maven to build a Java application, you can just add another target to build a complete VM for that. And then those VMs, you can create one for VirtualBox. If you want it on your laptop, you can create a VM for VMware. You can create one for Zen, for Amazon Cloud. So we're really tying the VM build into the application build. So let's take a look at that. Let's see how that works. All right, I'm going to see the build.xml file for a simple Java project here. As you can see, we have a target called jar, where we're just building a jar. That was the last step in this build.xml. But now we're just adding another target. And this is a target called VM. It depends on the jar. And what it's doing is taking that application jar and building a VM image around it. We have a tool that we're invoking from Ant here called Capstan. It's driven by a single file. So we're just writing out our Capstan file from Ant. We are saying which files go into it. We're putting our jar in. We are specifying a base image. In this case, we're specifying a base image that has OSv and OpenJDK 7 in it. We can also pick one that has an OpenJDK 8 or whichever JDK package you happen to like. Finally, we're specifying command line, and this is the one thing that is going to run when that VM starts. And we're taking Java, we're starting a jar, and that's the jar that we've built in this Ant build XML. After we write out the config file for Capstan, we invoke Capstan, we say build, and we give it the option to build it for the hypervisor we want to run it for, and it's creating our VM file. So this is actually just 12 lines of Ant code, and that takes you from a simple application build all the way up to a VM build. So let's see how this runs, how long this takes. All right, I am in my project directory here. I'll just issue an ant clean. Everything clean, nothing up my sleeves here. So I'm going to say ant VM and keep track of how long this takes. Building our jar, and now we're wrapping it up into a VM. And there we go, 9 seconds. And there it is. That is our VM. So you can see that these VMs come out pretty small if you're used to looking at VM images for other operating systems. A 90 megabyte complete VM is on the small side. Okay, so now this is my virtual machine manager, so I'm just going to pick that VM image that we just built, and I'm going to start it in the hypervisor. Say forward, we're going to accept the generics and give it a small amount of memory. Really creative name there, VM1. All right, and it's booting. Our virtual BIOS is starting up. And there's our application running. So real simple, and we can go back into Ant and add these to run VM builds for whichever hypervisor we want to build them for. Any questions on this part? Okay. Oh yes.
So is it going to assign a different IP address to this, or everything is local to the host machine?
That is done by DHCP by default, although you can pass configuration in to OSv to specify the IP address at boot time if you like. So
there is one other technology called Dockers. How different is it from
Oh, this is very, very different from Docker. The problem that we're solving in a lot of ways is fairly similar, but the end point of building something with OSv is a VM image that you can then take and run anywhere. VMware, VirtualBox, KVM, Google, Amazon, wherever. Once you've built a container with Docker, then that's a Linux level container that you would then need to have a Linux and Docker environment to go run that with. So once you've built a container, you've solved part of the problem, but now you have a problem of what's my container running environment that I'm going to use for this. On OSv, you take a VM image that's built for any hypervisor, run anywhere, you're already good to go. Yes?
You were all talking about networks. Is it possible if I map multiple networking interfaces into the virtual machine? Are we able to handle that?
How many network interfaces can we have on the VM?
It's is it working here? Yeah. So it's effectively unlimited because this is something that belongs to the hardware, not to the operating system, right? So if you remember what Don did there, he created a virtual machine and when you create this virtual machine, you specify what kind of hardware this virtual machine has. He just clicked default because this is a demo, but whatever it's there in terms of hardware, we're going to pick it up and use it.
Visible to the application.
Oh yes, yeah. So again, your application is coded for the Java virtual machine, and the Java virtual machines expects the operating system to provide those abstractions. We provide those, but we provide those in a very simple and streamlined way. That's the only difference, isn't it?
Yeah. So if your hypervisor gives you multiple virtual network devices, then OSv can just go ahead and use them. All right, great. Question in the back.
How about graphical displays? I mean, there's libraries which require, let's say, an X server. How would you deal with this?
At this moment, OSv is focusing on server applications. So we're running headless and focusing on the kind of applications that are server class and don't require it. We do have a VGA driver. So if you want to run it, but we won't provide you with an X server, for example. So if it's theoretically and architecturally possible, it's just something that is not our target at the moment, right?
Yeah. And the VGA driver is basically there so that it'll run on VirtualBox without complaining.
Yeah.
Yes, question in the middle.
How about things like mapping network mounts and stuff like that?
Network mounts.
You mean network file systems?
Yeah, like I'm thinking, I want to write some persistent data somewhere. How am I going to do that?
So again, we're going to GA in a couple of months, so there is only a question of what we target. So we're hearing a lot of interest in people using NFS. We're thinking about implementing this, but right now, the kind of applications, again, we're targeting and is something that talks to an external database like Cassandra, and then your data is just going somewhere. We do have a local file system because applications need it, but at this moment, the kind of use that we envision for OSv is like stateless machines that talk to remote storage like Cassandra, like MySQL, for example. We do have all of those applications running on OSv, but your code is probably connecting to some of them as well, and that is what we target at the moment.
So you just showed a Tomcat, right?
Mm-hmm.
So when, let's say, I'm running an application on Tomcat, it's writing some logs over where.
So yeah, that goes to the local file system, and that's the reason we have a local file system. And if you have any kind of service that streamlines those logs somewhere else, then fine. That is possible to be run as well. But by default, you're probably going to be writing local logs, and that's what we have the file system for.
Yeah. But if your application has logging over the network, then those will go over the network.
We run the ZFS file system, by the way, I mean, in case you're interested in details. So it's just...
Yeah. Yes, question in the back?
Can I run OSv on the real hardware?
No.
No, we currently don't have the device drivers for it.
We don't plan to do it, but it's also possible. It's just a matter of writing the drivers and dealing with the problems that will certainly arise from the various firmware implementations. Virtual machines are nice because they provide you with an abstraction that is always the same, right?
Yeah.
Should we move on? With
Yeah,
our
sure. And OSv is open source, so if you are interested in implementing something like a device driver for some physical hardware, then please get on the mailing list, and it sounds like a good project. All right, so once we've got our VM built, as Glauber pointed out, on a classic operating system, you've got a lot of management touch points, a lot of places where you can see what's going on with the system. On OSv, we've simplified that quite a bit. We actually have everything that you might want to manage or troubleshoot or have a look at is all exposed through a REST interface. So let's go ahead and have a look at that. All right, this is our main dashboard here. We're at a little bit of a lower resolution than normal, but you can see that it resizes. It's displaying an animated graph for CPU usage. I've got a little script running to keep it busy. It'll give you the percentage CPU for all the processors on the system. You get a nice graph for disk usage. So all the basics, the bottom OS level basics are right here in the management dashboard. Now you do not have to build every OSv VM that you build with all this JavaScript and all this nicely styled interface on it. You can always build just the bare REST server side and leave this off. But this is really handy for when you're starting up a new VM or making some changes and you just want to drill through and see what's going on. So each of those items that shows up here, the host name, memory, uptime, every little item is a REST endpoint, and we have this sort of self-documenting interface for covering all of those. This is a nice project called Swagger that we've integrated. And so if you want to get your total memory available on the machine, you can just go into OS memory total, and it will document what's the correct URL for you to hit. It'll give you the response body. It'll tell you exactly what you'd need to do in order to write a script to work with any of this information. Let me take a look at one that's a little more complicated. This is OS Threads. OS Threads gives you back a JSON list, and this includes the status, the name, and the stats for every thread on the system. So instead of having to work with a lot of different management tools for different layers of your project, you can see everything in one place. It should save some time. All right, let's go back to the OSv interface here, the main dashboard. We'll have a look at our Threads tab. Something up with my browser here.
I think your poor laptop is overloaded with too many VMs, like the other one that is already running.
All right.
This is all local, so
Yeah. Okay, so I'll go back to the another tab here. Okay, yeah, that's the browser, JavaScript objects leaking. So here we have the thread status for the system. We can see every thread that's running and how much time they're taking. We can scroll down, see the state of every thread on the machine. VirtIO RNG, this is a fun one. That's the random number generator. There's libHTTP server. That is not a web server application on OSv. That's just the HTTP server component that's powering this interface right here. Now under traces, we can see every trace point in the system has the ability to search for it and find it in this search area over here. So let's say we wanted to trace TCP output. Just put in TCP output, and there it is, graphing it. 55, that's 57 TCP packets output per second. Let's add in another one. Let's say we wanted to compare our TCP input ACKs. That's ACK packets coming back. And there we've got another graph for input ACK as well. So you can really go back and see every single trace point on the system directly from the REST interface.
Quick question. Is it possible
Yes.
for the app to integrate its own metrics into that?
Yes, I will actually point that out right now. This is Cassandra. Now, Cassandra is a good example of an app for us to use. Cassandra uses JMX, and all the JMX endpoints are available through REST in OSv. So, for example, Cassandra completed tasks. This is all being updated in real time, and we can see it over the REST interface. Here is database transactions on Cassandra. Again, it's a JMX item that's being exposed through REST.
Moreover, as Don pointed out, the interface itself, although very useful, it's more of an example, right? It's nice to have something that boots up and you can use it and you can browse it, but the real power of all of this is that everything is REST. So if you already have your monitoring system, you don't have to use this interface. You just integrate all of those REST endpoints with your monitoring. If you don't have a monitoring, you want to use it, that's why we have it, right? But we're not trying to change the way you do your operations.
All right. Any other questions on this part? Yes.
So each JVM is on each OSv, right? We can't have multiple JVMs on one OSv, right?
No, you have one JVM on one OSv VM.
So when you have multiple OSVs with JVMs,
Yes.
side by side,
Yes.
how does the clustering work?
Well, the clustering.
We want to go back to the microphone.
Yeah, back to the mic. Okay. There isn't really clustering at the OSv level, but for example, an application like this, Cassandra, where the whole point of the application is its own clustering, then OSv has the ability to pre-populate those nodes with the information that they need in order to join their Cassandra cluster. So we've got a mechanism called We've got a mechanism for populating those VMs with their configuration info at boot time. So you can take the identical VM image and use Cloud Init to set the configuration for joining its cluster where it's supposed to be and joining the correct cluster.
So the multicast, unicast still applies here for the communication, or is it totally different mechanism?
Multicast. Have we done multicast?
Yeah, I mean, we support a full TCP stack, right? And all of that is outside of this domain. Again, the good thing about a library operating system is that it feels like a library, but it really provides you with everything the operating system has. And so whatever you have, like a full TCP stack, a full UDP stack, like a memory management, all of that is provided, right? So it's,
Part of the OSv.
yeah, we try to implement as much as the POSIX API as possible. Some of it is not architecturally possible, but it's nothing that influences Java. All right, so everything that Java needs from the operating system is there.
Yeah. Yes.
So you're taking all the JMX stuff, or putting it out as REST. What about just direct access into JMX? There's a lot of monitoring tools like Cache Annex that hit the JMX directly and can already bring all that stuff.
Yeah.
Are you still keeping those ports open and available?
Yes.
Yeah.
As I said, I mean, this is not really the business of the operating system. So whatever you do, those are all examples. We want to save your time, not make you spend more of it. So whatever you're already running is probably, except for possible bugs, they're going to run on OSv as well. So it's not the domain of the operating system. The ports are there. If
What about the things that you're exposing via the REST API? Are you also exposing that inside JMX?
you mean the things that are for the operating system? We expose it through JNI, not JMX. So you load it against a library, what is libosv.so. So if you ever use JNI or JNA, actually we do both. You have access to every function in the kernel, and you can call it from your application. At the moment, there is only a handful of them that we provide as native Java interfaces, but in the future, it's a fairly likely direction for us to take.
Okay, just a little bit of feedback. It would be useful
Okay.
for all those monitoring tools like HappenUX or something like that for you to be just exposing those as MDs in the JMX.
No, so if they are something that Java already provides, they're there.
Right, but I'm talking about from your OS perspective.
Yeah.
That would be useful as well. And then you can have automatic access.
Yeah, it will be, I mean, if you want to talk more about that later, because we do provide, of course, something like memory. Java, the Java virtual machine already provides some of it, like how many threads. So those are there. If there is anyone in particular that you would be interested in, I mean, we can talk more. And again, we're more than happy to support your use cases.
Yeah, you can drill down to existing MBeans, but as far as packaging up the existing OSv interfaces as MBeans, we should talk about that. Yes.
Can you show how it runs in the cloud?
How it runs in the cloud? Actually, we're not set up on internet right here for this demo, but it runs exactly the same in the cloud as it does locally. As a matter of fact, OSv comes with a little simulator script to simulate starting up an image under Amazon EC2, which was originally just for our practice in making sure that we have something that'll deploy to EC2, but it runs exactly the same way on Amazon as it runs locally.
Let's move on then. So
Yep,
maybe
okay.
getting short.
All right, so this is the JVM tab, and here we can just see this is the total number of garbage collection cycles that this JVM has gone through since we booted. Here's heap memory usage. This is a Cassandra VM, so it's periodically garbage collecting, as you might expect. And then, as we briefly mentioned, you can actually drill down to every MBean that's exposed by this JVM and every MBean on the system. All right, so that's about it for the interface. And again, everything that you can see in the live updating cute little interface, you can also drill down and see from your own scripts that you might write, or any management tool you want to hook up to it. All right, so performance. This project has been designed from the ground up with the idea of let's simplify things, let's make our development and deployment cycles go faster. What about the actual performance of the system? Well, Redis is a very common NoSQL workload. And here we compared OSv against Ubuntu Linux. And on some of the common operations, such as get from a Redis key, OSv comes out to be about 80% faster. There are a few operations that are more CPU intensive, like set membership, and you can see those don't really use the operating system service as much, so there's not as big of an advantage. But for a lot of these common operations that involve a lot of I/O, big advantage to running OSv over a generic Linux. Cassandra, this one is a work in progress. It's more complicated. Here we're seeing on a sustained load, after the JIT settles down, on a sustained load it's about 25% faster on OSv. And this is one of the workloads that we've had a lot of interest in, and we're doing a lot of tuning around Cassandra. So this is, these numbers are changing all the time. So improvement in process. We also have a 3.9x improvement on a specific OSv tuned Memcache D, which is a project that we just did as a demonstration to see how fast you could make something like a simple key value store go on our design of OS. So as Glauber mentioned, I'd like to ask everyone who's got a question later on, or an application that you're interested in running, or even a class of applications, please go ahead and post on Twitter with hashtag OSv and mention the application that you'd like to run or the type of application you'd like to run, and we will get back with you on Twitter very shortly. We will be following this hashtag and posting things as we come up with them. In a lot of cases, there might already be somebody who has done OSv support for that application, like MySQL or Tomcat, and we can go ahead and post the link for you to the existing example of that application running on OSv. And thank you all very much for coming. OSv is open source, so please visit our website and try it out. There are instructions and downloads there. If you would like to try it on Amazon Web Services, it will run on the public cloud, so just click the Try It on the Cloud button. And we have a Twitter account for miscellaneous updates, so please follow Cloudius Systems on Twitter. Thanks again for coming, and any final questions? Yes.
What's your planned revenue model for the OS?
It's still early stages. Yeah. We'll post on Twitter, so follow us on Twitter.
Yeah, and as we may be running out of time, I mean, if we do run out of time, we'll be around, and don't shy away, just come in.
Yeah.
But your questions.
I was just wondering, for the management interface, is there any sort of authentication or security?
We do run SSL, but again, this being a demo, we just there, right? But it's all whatever you do over REST, you do over OSv. We do support SSL. We do support all of those libraries. So the idea is that those REST APIs, they're not going to be just open, right? We imagine that whoever is deploying this will secure it somehow, and we're just going to give you the tooling to do that.
Yes.
I would assume that an OSGI container inside OSv should be straightforward, right?
Is it a what?
OSGI container?
OSGI I think so.
Yeah.
Don't see why it wouldn't work.
Well, we will value too. This was very interesting.
Yeah, thank you.
Oh, thank you. Yes.
How about security of the OSv itself? I mean, is there additional attack vectors?
That is a really interesting question, and so this is certainly one of the design criteria that we looked at in coming up with OSv. And if you look at the total number of lines of code and total attack surface for a library OS compared to a full-featured OS, it's an order of magnitude less in lines of code.
Okay.
And if we were at a C++ conference, which we're not, but come see us at a C++ conference, then we could talk about things like how we're using some of the standard constructs within C++ to do some of the tweaky OS kernel level stuff in fewer lines of code in a way that's easier to understand and more explainable and reviewable than some of the hand bit tweaking that has traditionally been done in the OS area.
If I may extend on that, onto your question about Docker, when you run Docker, and this comes from the point of view of a person like me who I actually implemented a lot of the container technology in Linux, aside from the big attack surface that a general purpose operating system has, when you run Docker, you're running a container, which is, it doesn't really isolate you that well. There is not the use case for container. Like containers allows you to span a lot of things in parallel, but the isolation between them, because they're using the same kernel, is less than perfect. And if you need this kind of isolation, you definitely should not be using container. It's for a different use case. OSv gives you a full VM. So you have the hypervisor level of protection. One virtual machine fully isolated from the other by VMware, Xen, KVM, whatever provides you. So we have the hypervisor doing the strong hypervisor isolation that you need for multi-tenancy, for example. And we inside the hypervisor a very slim, low attack surface operating system, or a library, as I like to point out. Yeah.
Some people say unikernel.
Yeah.
So
There are interchangeable terms like unikernels, library operating systems, and like I like library operating systems a lot because I don't know what a unikernel is. It's like I mean I know, but it's not an obvious from the name. And a library operating system tells you exactly what it is. It is a library. It is something where your application is the master, and we just bow to you. That's what we like to do, not the other way around.
Yes, up front.
I have two questions actually. The first one is it a standard OpenJDK that you
Yes.
run, or is it some modified distribution where some strange
No.
side effects might occur?
Well, there are things that we do that integrates with the JVM, right? So as the ballooning example I've shown you, again, I'm an engineer, I'm talking about technology, not about magic. So there are bugs and there are things and there are things that you might encounter. But all of the things that we try to do to integrate with the JVM, I can give you details about the ballooning, for example, later. We try as much as possible not to touch the JVM code base. So all of the ballooning, for example, it happens on the operating system level through JNI. And if we need it, we maybe would change it, but we didn't. So we have a different class loader that make sure that some things are the way we expect. But all the runtime environment is completely unchanged. In our case, for the public image OpenJDK, you pick it 7 or 8, standard, no modifications. Everything we do is on the outside, is a library.
Yes, up front here.
So what happens like in case like there's some issue going on in the JVM, like some threads, like I'm seeing some concurrency issues, some thread dump happens. So what happens to the virtual machine you are running?
If the JVM dies on you, then the whole OSv VM also dies on you. It's one process.
So how do you debug that? Like, can we take a thread dump or something like that?
If you can do it, again, if you can do it with the JVM, you can do it with OSv. So we do have a file system, for example. How your VM dies, so how does that happen, is actually something that you set on your hypervisor. Like, should I just crash the VM or should I leave the VM alive? That's what we usually do. So your VM is there, your VM is alive, and your VM is responsive, right? It's just, it doesn't shut it down unless you specify on problem want to shut it down. So the VM is there and the VM is responsive. Of course, if you dump anything to disk, The disk is there. That's why it's there. So you can log in later on a new session. Log in without the JVM even, on a just pure kernel OSv plus REST, and get whatever information you get from it.
So
Right?
OSv host will be there, the OSv session will be there even though JVM is died.
Yeah,
Okay.
pretty much. It's just that because it's a library, it's not very useful for you to have, you don't have other applications running. So your VM is effectively that, but it's not technically that. So you can still, do you have, let the guy in red, because you're with your hands raised for a long time.
Back to permit.
It would be technically possible to actually use Docker itself, because we're not actually competing with Docker, right? It's a different thing. I mean, I'm not
looking for a way to work with Docker.
Oh yes, yeah,
To gain those particular
yes.
composability things. That's what I'm.
So this is not something that we are doing ourselves, because we're focusing on a different level, but it's definitely something we envision being done, right? A lot of people ask us about Docker, all sorts of questions, and if you look at what we have been saying, it's really just not the same thing. I mean, Docker does one thing and it does it really well, and OSv does some other thing, even though there is some overlap in some of the problems we solve. So it's technically possible to use Docker. Docker have those recipes. We have this tool called Capstan that Don mentioned that does some of the things that Docker does, but again, it's a small overlap. And once you have those Docker files that allows you to specify what to do, as we shown you in the Ant example, you can just say, as this last step on Docker, build this VM. And then you use the rest of Docker to integrate. I mean, it's not something that we are looking at, but it's something that is completely feasible and possible.
A lot of it depends what level you choose to solve the problem on. If you have a VM management capability, if you've got one of these VMware experts who's checkpointing and moving and cloning VMs all over the place, then in that environment you may be a lot more comfortable having developers build VMs and just hand the VMs over to be managed that way.
I think we have to close this down because it's 1:30 already. We have probably the next speaker around.
All right.
Yeah.
So,
We'll be outside and happy to talk to any of you. Bye.
right, thank you.